Hi dear students, welcome to another video of 8th standard physics. In the last class, we mainly discussed about pressure. Pressure, that is the force exerted per unit area of a surface, is known as pressure. And we discussed about liquid pressure. What is liquid pressure? Do you remember? Yes, that is the answer. Liquid pressure means the pressure exerted by a liquid on the walls of the container and at the bottom of the container. That is liquid pressure. That means liquid pressure can exert a force on the unit area of the surface of the walls of the container. That is liquid pressure. It will be experiences at the bottom of the container, and sidewise pressure is also experienced. That sidewise pressure is we called lateral pressure. What is that? Lateral pressure. Then what are the factors that depends liquid pressure? Do you remember? What are the factors? Yes, that is the answer. That is, the factors that depends liquid pressure is, one is the depth of the liquid. The depth of the liquid or the height of the liquid column, that is the one of the factor that depends liquid pressure. Today we are mainly focused about another pressure, that is pressure experienced by the air. That is known as atmospheric pressure. What is that? Atmospheric pressure. Atmospheric pressure. We know that we live in our earth. There are a lot of air is surrounding us. Do you know that? We live in our earth's surface. There are a lot of air surrounding us. Then can you feel the weight of the air that is surrounding us? No. But we know that air is a matter. Matter has weight. You know that matter has weight and it requires space to occupy. Isn't it? You already learned in the lower classes. Matter has weight or mass and it requires space to occupy. That's why air is a matter. That means air has mass. Air has weight due to the gravitational force. Why the atmosphere is placed on the above the earth? Due to gravitational force of earth. Then what is atmosphere? What is atmosphere means? We know that the air is surrounds above the earth like this. This is earth. Consider this is earth, and the region where air around our earth is known as atmosphere. What is that? What is atmosphere? The atmosphere is the air envelope surrounds around our earth is known as atmosphere. Then do you feel any weight of this air? No. But there is a weight of air experiences on the surface of the earth due to this air column above the earth's surface. There are a lot of air columns above the earth's surface. It will experience a weight towards the center of earth due to gravitational force. Okay, and this weight of air that experiences on the surface of earth is known as atmospheric pressure. That means the pressure experiences by the weight of the air in the atmosphere on the surface of earth due to its weight is known as atmospheric pressure, or pressure experiences on the surface of earth due to the weight of air is known as atmospheric pressure. Do you understand? Yes. And then what is the range of atmosphere? There are so many kilometers that extend over our Earth's surface, that is the atmosphere. Then how many kilometers air is enclosed in our atmosphere? Then the weight experiences by this air on our Earth surface, that is known as atmospheric pressure. Do you understand? The atmospheric pressure on Earth's surface at the sea level is about 100 kilopascal. What is that? 100 kilopascal. Okay, that means the atmospheric pressure that experiences on the Earth at the sea level, that is 100 kilopascal. Then if such a huge amount of pressure is experiences acting on us, why do we not feel it? This is because the pressure of our blood in our blood vessel and other fluid present in our body that balance the atmospheric pressure. That's why we cannot feel the atmospheric pressure at this value. Okay, do you understand? Then how can we feel, how can we experience atmospheric pressure? Let's go to another activity that can be observed the enormous atmospheric pressure in our daily life. Through this activity, you can feel, you can identify the presence of atmospheric pressure around us. Through this activity, you can identify, you can understand the presence of atmospheric pressure around us. Let's do the activity. The aim of this activity is to show the presence of atmospheric pressure. That is, we want to feel the presence of atmospheric pressure. That is the aim of this activity we are going to see. Okay. Then what are the things that is needed to this activity is one of a glass tumbler. Okay. Our glass. Then another a piece of thick cord or a piece of thick paper. And we want water. Okay. And these are the things needed for this activity. Then how can we do this activity means, first we want to fill this glass tumbler, that is up to the brim of glass, with water. Okay. And I takes water up to the top level of the glass tumbler. Okay. Then next we want to do that, and then I cover this glass with a piece of paper here. Okay, with a piece of paper I covered this glass. Okay, then I press the piece of paper, thick paper, very hardly, then so that there is no air in the glass tumbler, that is because it is full of water. Then next I am going to keep the card in the position with one hand, and then I am going to invert this glass tumbler, that is full of with water. Okay, that is full of water. Then I turned, this just inverted this glass tumbler that is full of with water. And if I withdraw the lower hand, what will happen? Can you observe? Yes. What is your observation? Yes, it is an amazing observation. If I withdraw this hand supporting this cord, what is your observation? Yes, you can see the piece of paper does not fall through the glass tumbler. That is full of water. Then we know that the water inside this glass tumbler have weight. The weight experiences the glass tumbler towards downward direction. but this paper that push this glass weight of water in upward direction, the weight of water is balanced by this paper. How? That is why the presence of atmospheric pressure. Atmospheric pressure exert a pressure on this paper in an upward direction. That atmospheric pressure that balance the weight of water that included inside the glass tumbler. That is your observation. First you say, what is your observation? The card does not fall because the atmospheric pressure act on the card in the upward direction. That means card means here paper. Okay. Then the upward atmospheric pressure acting on the card is greater than the downward weight of the water on the paper. Then what is the conclusion? Here this activity shows the presence of enormous atmospheric pressure around us. What is that? This activity shows the presence of atmospheric pressure around us. Here the atmospheric pressure is experienced in upward direction. From this activity we observed that atmospheric pressure that experiences in upward direction. That means atmospheric pressure not only experiences in upward direction, it is also experienced in downward direction and in sideways direction. Okay, sideways direction atmospheric pressure experiences, upward direction atmospheric pressure experiences, and downward direction the atmospheric pressure will be experienced. That is our conclusion from this experiment or activity. Do you understand? Again, if you observe this figure, we know that here where will be the atmospheric pressure experiences at maximum rate? Where will be the highest atmospheric pressure on the earth? We know that atmospheric pressure is the total weight experienced by the air on the unit area of the surface of earth, that is atmospheric pressure. That means if one of the person is standing here on the earth, means the atmospheric pressure experiences on the body of this man will be the total weight of air column that experiences on his body. That is the atmospheric pressure experiences by this man. Then where will be the value of atmospheric pressure maximum means, because the total weight experiences towards the center of the earth due to gravitational force, that means the total atmospheric pressure maximum at the surface of earth. Okay, that means the atmospheric pressure is maximum on the surface of earth. When we go to higher altitude, like a mountaineer that climb up a mountain, they goes to higher altitude, means then the atmospheric pressure decreases. When we goes to upward direction in the atmosphere, okay, from the surface of earth, if it goes to upward direction, higher altitude, then atmospheric pressure decreases. Why? The presence of density of air in the atmosphere is greater near the surface of earth. If it goes to higher altitude, means the density of air decreases, that means atmospheric pressure decreases. When we goes to upward direction in the atmosphere, atmospheric pressure decreases. Then what will happen for the mountaineers? If the mountaineers climb the mountaineers suffers nasal bleeding at high altitude, because at high altitude atmospheric pressure is much lesser than their blood pressure. Much less than their blood pressure or body pressure. Due to this, some of the blood capillaries burst and blood comes out through the nose of the mountaineers. Okay. Likewise, astronauts, they wear special suit when they goes to space. What is the reason for that? The reason that if they wear special suit means they maintain their body pressure inside the suit, because there is no pressure outside the atmosphere of the earth, because there is no air in the outside of the atmosphere of earth. In the space there is no air means there is no atmospheric pressure in the space. And if the astronauts, they are going to the space, wear special suits, special wearing suit. Why? Because to balance their body pressure. From nasal breathing, they want to balance their body pressure. That's why they wear special suit when they goes to the space. Do you understand? Yes. Then next we are going to discuss what are the application of atmospheric pressure in our daily life. What are the application of atmospheric pressure in our daily life? The application of atmospheric pressure are listed here on the whiteboard. Listen here. Application 1 is drinking juice using a straw. We can able to drink juice using a straw. That is one of the application of atmospheric pressure. Okay, we will explain that. Then next point is working of a syringe. But working of syringe is also application of atmospheric pressure. Then fixing rubber suckers on polished surfaces. Fixing of rubber suckers on the polished surfaces is also another application of atmospheric pressure. Then let's explain each one of these. That is drinking juice using a straw. That means you normally use a drinking straw to drink fruit juice. When you suck air at the up end of the straw with your mouth, the pressure of the air inside the straw will be reduced. Okay. But the pressure acting of surface of juice is equal to the atmospheric pressure. So the greater atmospheric pressure that experiences on the surface of juice pushes the fruits juice up into straw to your mouth. That is the application of atmospheric pressure. Okay. And second is working of a syringe. Okay, when we dip a syringe into a liquid and pull its piston, then the pressure inside syringe gets reduced. Then atmospheric pressure acting on the surface of liquid is more compared with the pressure inside the syringe. Then the atmospheric pressure pushes the liquid into the syringe very easily. Then the liquid moves from higher atmospheric pressure to lower pressure inside the syringe. That is the working of syringe. Here application of pressure is done. Okay. Another is fixing of rubber suckers. We already observed that rubber suckers pads used on the walls to hang clothes, calendar, etc. When we use good quality rubber suckers, then it will be pressed against the smooth plane of the wall. Then the air between the suction pad and the wall will be forced out and reducing the pressure inside the rubber suckers. Then the outermost atmospheric pressure that will be greater will be pushes the rubber suckers on the walls tightly. Okay. Then the outer atmospheric pressure being greater and pushes the rubber suckers on the walls, and it will be help to stick on the surface of the wall. That is the application of another application of atmospheric pressure. The figures are given in the display, and using this display you can understand how rubber suckers are work. Here atmospheric pressure pushes the rubber suckers on the wall, because inside the rubber sucker pressure is reduced due to the pushing out of air inside the rubber suckers. That's why atmospheric pressure is greater in the outside of the rubber sucker. It will be pushed. Rubber sucker will be pushed on the walls and it will adhesive to the wall. That is the one of the application of atmospheric pressure. These are the topics we are discussed here. That means mainly atmospheric pressure. Then what is atmospheric pressure? Atmospheric pressure is the pressure exerted by the air of atmosphere due to its weight on the surface of earth. Okay, and another point is atmospheric pressure will be experienced in the downward direction and upward direction in sideward direction. Then if we goes to upward into higher altitudes, atmospheric pressure will be decreases. The maximum value of atmospheric pressure will be on the surface of earth. When we goes to the upward direction to higher altitude, then atmospheric pressure decreases. That is the reason for when the atmospheric pressure decreases, due to the decreasing of atmospheric pressure, nasal bleeding that may be occur for the mountaineers and it may be occur for the astronauts. So therefore they wear special suit. Astronauts wear special suit to balance the atmospheric pressure with the space. And last we discussed about the application of atmospheric pressure. One is when we drinking straw and working of a syringe and a rubber suction pad, and in these all the situations we apply atmospheric pressure. Okay, we experience atmospheric pressure. These are the topic. Our chapter is completed. Up to this topic our chapter is completed. Next we want to do the exercise regarding this chapter. Okay, let's do the exercise regarding with this chapter and send to me through my WhatsApp number. That is your follow-up activity. Thank you for watching my video.